Welcome everybody to our presentation. We continue our discussion on techniques of integration. This is Magda Talib Al-Hinai from Sultan Qaboos University and I welcome you all. We start our presentation with an example. So let's see the following example. Our first example in this presentation will be integrate x cubed plus x all over x squared. And as usual, I start my solution putting this integral equal to I. This makes it easier later. Instead of writing the whole thing, we can write just I. Here we have I is equal to. We see that we're having one denominator x squared. We will split it into the sum of two fractions as follows. We have x cubed over x squared plus x over x squared dx. And this is the integral we will be integrating term by term. But of course, we can see that there are some simplification and cancellations we can do. The x cubed cancels with the x squared. So here we have, yes, x cubed over x squared is x, and the x over x squared is 1 over x. And we go integrating term by term. The integral of x dx plus the integral of 1 over x dx. The first integral is, yes, x squared over 2. The second integral is, of course, as we all know, it's the logarithmic function, ln x, but we don't just write ln x, we have to put, yes, the absolute value, plus the constant of integration. And that's the integral we are looking for. Let's see this example. Integrate 2x cubed plus 3x squared plus x plus 1 all over 2x plus 1 with respect to x. Solution, we take this integral and we call it I. So here we see that we have a fraction, it's a rational function. We have a polynomial in the numerator and a polynomial in the denominator, and the degree of the polynomial in the numerator is higher than that of the denominator. So let's think of making long division or synthetic division, whichever easier for you. You can do it here. I'm going to do long division. I remind you of long division. I write 2x cubed plus 3x squared plus x plus 1 to be divided by 2x plus 1. And here we take the 2x cubed divided by 2x. The answer is x squared. Then we take the x squared multiplied by 2x. We have 2x cubed. And then multiply the x squared, again the one in red circle, with the 1. So we get x squared. Then we subtract what we wrote right now. So we change the sign to be minus. Now we see that 2x cubed and minus 2x cubed both add up to 0. Here we have 3x squared minus x squared. This is 2x squared. And then comes down the x and the 1 as we see in front of us here. Next, we take the 2x squared divided by 2x. So we get x. And then we take this x multiplied by the 2x. So that we get 2x squared, and multiplied by the 1 so that we get dx. Again, we change the sign. We see that the 2x squared and the minus 2x squared, they add up to 0. The x and the minus x, they add up to 0. And here comes the 1 to be the remainder. So our integral I will be rewritten in the form of x squared plus x plus 1 over 2x. And we all know that the 1 is the remainder we got over there. So we want to integrate this term by term. The first term is the integral of x squared. The second term is the integral of x. And the third term is the integral of 1 over 2x plus 1. Okay, we all know how to integrate x squared. Simply it's x cubed over 3. And we can integrate also x with respect to x. It's x squared over 2. Plus the third integral, I will call it I1, integral 1. And I'll go to the margin and I'll do the integration by myself. So this is the I1. I write it in red. It's the integral of 1 over 2x plus 1 integrated with respect to x. I will take the denominator and I'll put it equal to t. Now, the old variable is x, the new variable is t. We want to find the relation between the dx and the dt. So we differentiate both sides and we find that dx is equal to dt over 2. So I1 now will be rewritten in terms of t. I1 equals half dt over t. We all know that the integral of dt over t is the logarithmic function. So I have half into ln absolute value of t plus the constant of integration, or again in terms of x, half ln absolute value of 2x plus 1 plus the constant of integration. Now we take this and we go to our integral over there. We put the x cubed over 3 plus the x squared over 2 plus the I1. We have it in red and that's it.
Now let's do the third example in our presentation today. Integrate 1 over square root of x into square root of x minus 2 all cubed with respect to x. We start our solution putting the whole integral as I equals integral of 1 over square root of x into square root of x minus 2 all cubed dx. I will take the square root of x minus 2 in the denominator and I will put it equal to t. I'll make the substitution. So now the old variable is x, the new variable is t, and I want to find the relation between dx and dt. I will rewrite the equation in front of us. Instead of square root of x minus 2, I will write x power half minus 2 equals to t. Now, I want to find the relation between dx and dt, so we have to differentiate. The derivative of x power half is half into x power minus half dx. This is equal to dt. Or equivalently, we can say that dx over square root of x is equal to 2 dt. From this equation and this equation, we go and substitute in the integral in front of us. Let's call the integral in front of us equation 1, and the substitution we made, we call it equation 2, and the differentials, we call it equation number 3. We notice that dx over root x is equal to 2 dt. So we make this substitution. And also don't forget that root x minus 2 is t. We make this substitution. So follow the colors and see how will the first equation look like now. Yes, the integral is equal to 2 integration of dt over t cubed. This is equal to 2 into integration of t power minus 3 dt. We all know how to integrate t power n. We add 1 to the minus 3 and divide by minus 3 plus 1. So this is equal to 2 into t power minus 2 divided by minus 2 plus the constant of integration. Now we can cancel the 2 in the denominator and the 2 in the numerator. So we arrive at minus. Instead of t, we will replace it by square root of x minus 2, this all power minus 2 plus c. Or equivalently, we can put it as minus 1 over root x minus 2 all squared plus c. And we move to the following example. Okay, so let's see this example. Integrate 2 power 3 minus x dx, and let me grab my laser pointer and I come back to you. There we go. This integral is having an exponential function, and the base here is 2. Can we change this 2 to be a natural exponent e? Okay, in order to do that, we need to remember an important property of an exponential function. Here I will put the I to be equal to the integral, and I'll take you to the margin so that I remind you of an important property of exponential and logarithmic functions. We know that e and ln are a function and its inverse. So e power ln t is simply, yes, t. So if I take this t and I replace it by 2 power 3 minus x, let's see what can we write. 2 power 3 minus x is the t. This is equal to, again in the same manner, e power ln 2 power 3 minus x. Now, we will use a property of logarithmic functions, which we can have this exponent down here. So this is equal to e power 3 minus x into ln 2. Now, let's see how can we have this in our integral. So I equals the integral of, instead of 2 power 3 minus x as I said here, I will replace it with e power ln 2 power 3 minus x. And again, I will do the same thing I said about bringing the exponent down here. So this is equal to e power 3 minus x into ln 2, and I'm reminding you of the property we used. So this integral is simply an exponential function, so the integral will be the same exponential function divided by the derivative of the exponent. Okay, so this is it. E power 3 minus x into ln 2, the same exponential function, divided by the derivative of the exponent, which is minus ln 2, plus the constant of integration. So can we take this back to its original form? What is the original form of this part? Yes, it's here. 2 power 3 minus x. So this is 2 power 3 minus x over minus ln 2 plus c. This is the integral we are looking for. And at the end of our presentation, we are going to see the following application where we are given the marginal revenue function dr by dq is equal to 900 over 2q plus 3 all cubed. And we are asked to find the demand equation. We all know that in order to find the demand equation, first we need to find the revenue. And in order to find the revenue, we need to integrate this equation. Okay, so to start integration, we will rewrite this in another format where we take the denominator up with a minus sign for the exponent, as we see here. Yes, 900 multiplied by 2q plus 3 all power minus 3. Now we integrate both sides with respect to q. The integral of the left-hand side is r. And here we have the integral of the right-hand side. We can take this 900 outside the integral sign. So it will be rewritten as follows. Now, in order to perform the integration, we take this 2q plus 3 and we put it to be equal to t. We make a substitution for this part. So here we have 2q plus 3 is equal to t, and this implies that there is a relation between dq and dt. The old variable is q, the new variable is t, and here we have dq related to dt through this differential. So we have 2 dq is equal to dt. Or equivalently, we can say that dq is equal to half dt. Now we make substitutions. We remove every 2q plus 3 and we put a t. We remove every dq, we put a half dt. So our integral will be, yes. Now I have a half from here. We can cancel this half with the 900 to get 450. So this, and we can integrate also t power minus 3 to be t power minus 2 divided by minus 2 plus the constant. So here we have the 450 from the cancellation, and here we have a minus 2 from the integration. Also, we can cancel the minus 2 with the 450, so we get minus 225 minus 225 into t power minus 2 plus c here. Again, we take the t and we replace it by 2q plus 3 so that we get this form. Now we are left with finding the constant of integration. In order to find the constant of integration, we all know that the revenue is 0 whenever the quantity is 0. So let's see. So here we say to find the value of C, we use that R of 0 is equal to 0. This gives us, I put here 0 and every Q I replace it with a 0. So this will give us 0 is equal to minus 25 plus C. Here I have 3 power minus 2. I put it down, it will be 3 power 2, it will be 9. And the 9 cancels with the 225, gives you 25, and the minus sign is still here. So we can find from this part the C is equal to 25. Now I take this 25 and I plug it in here, so I get the revenue function. Accordingly, the revenue function will be as in front of us. And now we want the demand equation, so we replace this by PQ. We take into account that the revenue is equal to price times quantity, or equivalently, price is equal to revenue over quantity, R over Q. I take this R and I replace it with what I found here. So the demand function will be in front of us in this part. And I take the first over Q and the second over Q. This is giving us the demand function which is required.